Hi, my name is Jorge Vasiliadis and I am the founder of WireTank, and in this video we are going to cover the use of the WireTank Tip Calibration URCap. So the steps that we're going to follow is that we will define a payload, we will define a TCP position. Once we have a well-defined TCP, we're going to do the definition of the calibration plane. We will then use that calibration plane and TCP to define the TCP orientation. We're going to look at the I/O that is going to sense the traveling of the TCP, the crossing of the needle through the sensor. What I/O senses that. We'll then set the cal height and the height limit, and we will measure offsets and finally have a calibrated TCP that then we can use in a program node. So to get started, we jump over to Polyscope. The first thing to do is to set the payload. So this assumes that you start with a blank program and a blank installation. And so the first thing is that we can use this wizard to set the payload. So we will essentially go through all of these different orientations. So we'll say next, we'll set position, we'll say okay here, we'll go next, we'll set another position here. We're going to be using the free drive and essentially go there, say set position, okay, we'll say next, we'll pick a different position. So we'll say set position, okay, next, and we'll set finally one more position. That might be like this. And we'll say okay, say next, and that will give us the center of gravity and payload, and we can finish. So once we have that, if we go now and we free drive the robot, it should basically stay in place and it should be very easy to maneuver, but it shouldn't fall besides that because we have a well calibrated payload. All right, so now we will go here to the TCP, and in the TCP we will set the position. Again, we will use the center point here. We will use that node to that little extruded tip, and we will go into that tip in many different in the 4 different orientations so that we can set our TCP. So this will be our TCP. We can actually create a new one that we call, and we'll set it as the default, and we'll call this one dispenser, so that we leave the original one as it is, and that we are going to be working with this one. So we will hit measure here. We will go to set point 1. And again, now we're going to be free driving the robot using the joystick. And we will start coming down here to meet up with this TCP. And so this process is made quite a bit easier with the joystick because you can, in step mode, set the steps to be all the way down to 0.2 millimeters. So that looks quite right for that. So we will say okay. We will set 0.2. So we'll go up. This next one will might align so that it does it actually quite straight. And we will again come over here. And we will start going down. And we will again come down very little by little so that we line up that TCP just right on top of that looks good. So we'll say okay. We'll set another set point. So we'll go up. We will free drive. We will go over now like that. Actually, we will free drive the other direction because we already did this one. We'll go something like this. And now we will come down. Okay, we'll say okay, and then we'll do one final point where we'll come up, and maybe we will free drive it this way. Now same thing, we will come over, come down, and okay, so now we have our 4 points, and we have set our dispenser TCP. Notice that we don't have an orientation yet. So the next thing we want to do is we're going to go up, we'll align again, and we're going to want to go here to features, and we want to set a plane, and we're going to name this plane Cal plane. We'll name it Cal plane, and we will teach this plane by going to the origin. So we will come down. So this will be our origin. So we want our plane to be defined like this, where this orange is the x-axis, this positive y, and then the purple is the z, positive z. So we'll come down here. And we will again line up this point here. Alright, so now that that is lined up, that will be our origin. We will say okay, we will say next. We will set up our x-axis. So again, this was our x-axis point right here. So we'll come up, move this out of the way slightly. So we will go down now. So that is now properly set up on the x. We will say set position, okay, next. And now we will set position on our y. So we'll go up, go over, and we'll come down. So we're moving over here to match it up. Okay, perfect. So now that we have that set up, that will be our y, next, and finish. So that is now our calibration plane. But now notice that our TCP is actually like this here, right? So we want to make sure that this lines up with this TCP. So if we were to go here now and say move here, this would twist up the robot because it would keep going and would try to line up the TCP that way. So we don't want to do that. So what we can do is that we can say now teach this plane again. We can go back to the origin and we can say move here. This will move right back to that. And if that's the orientation in which we want the TCP, right, in our calibration plane, so it can be like this, it could also be rotated, but in this case, we'll leave it like this. Then we can actually cancel out of this now, and we can go to the TCP and say that our orientation is going to be this point in the cal plane. So this is the orientation that we want in our cal plane. And so now that's taken the right orientation. So if we move up now, now we can go to our features and we can go to our cal plane and say move here, and then the robot will properly move to the origin of that calibration plane. So now we have a well-defined TCP and we have a well-defined calibration plane. So at this point, we are now ready to move to. We are now ready to go into our URCap. Oh, the first thing is actually in the I/O. We should check so that our digital input 0 is the one that when we cover, right, it's high when we don't interrupt the light beam and it's low when we interrupt it. So that's what we want. And so when we go here to our installation, tip calibration, we're going to say that digital in 0 is our sensor. We're going to say that cal plane is our calibration plane, and we are going to say that dispenser is our calibration TCP. So now that we have those things, we are able to say, go ahead and measure the offsets from this TCP and this calibration plane to the light beam. So we will go ahead and say measure offsets. So it will touch off the height. It will touch off on the x-axis, and it will touch off on the y-axis. And it will have measured these offsets. So that is essentially what we wanted. So now that we have those offsets, if we were to say calibrate TCP, then the idea is that the calibrated TCP will match exactly our current TCP because it has the same TCP as what we were using before. So whatever it will populate here will match very closely what is defined in our TCP. And you will see that the TCP will have lined up with the origin. So how do we actually go now and test this? So the first thing is, let's define a plane so that we can actually follow the sketch around.